Hi guys. All right, we're going to solve a complex equation, z to the 5 equals 32, where z is a complex number. So another way of saying that is we want to find the complex fifth roots of 32. Now we're going to be using the mod arc form to solve this. I've talked more about the mod arc form in a previous video, and I'll link to that at the end. Let's just summarize. EI theta equals cos theta plus I sine theta. If a complex number is z equals r EI theta, then you would multiply the r through, and you have that format there. In the Argand diagram, the r and the theta are such. R is the magnitude of the length of the vector going to the complex number, and the angle of theta from the x-axis. If z equals 1, for example, then the diagram is simply the 1 is there. There's no imaginary part. And the angle is just 0. And the possible angles, if you're not talking about the principal angle, you can add multiples of 2 pi to it. This is very important in solving these equations. So you just add multiples of 2 pi, where here n is an integer, plus or minus 1, plus or minus 2, etc. Right, so let's use that system to solve this one. So you've got z to the 5 equals 32, plug it in, use a bit of algebra, and you can deduce that r to the power of 5 is 32 and e to the I5 theta equals 1. So this is the part that we were looking at before. R equals 2. 2 to the power of 5 is 32, so that's easy. And then 5 theta is equal to 0 plus 2 pi n, where n is an integer. Solve for theta. And for example, you could put n equal to 0, 1, 2, 3, 4. And that's one way of writing it. Or usually they'll go plus or minus 2 pi and 5, plus or minus 4 pi and 5, which is the same thing, because you can just subtract 2 pi's from a couple of those. So plug it back into the original one here, and you end up with 2, 2e 2 pi on 5, 2e 4 pi I on 5, and so on. And these are all of them. Now they actually live on a circle in the Argand diagram, which I'm going to show you. Normally, this is the best way to put it, more succinct. And they're the principal arguments. In the Argand diagram, you draw your axes, you draw your circle of radius 2, you put the first one in, then there's the second one, third, fourth, fifth. They all live around the circle, equally spaced around the circle with the same angle. Let's draw the vectors in. And that first angle there, you can see there is 2 pi on 5, which in degrees is 72 degrees. So each one of these is 72 degrees. 5 of those times 72 is 360. That covers the whole angle. And that's a visual picture of the fifth roots of 32. All right, Bob's your uncle. Thanks, guys. Have a great day. See you next time.